All right, everybody, welcome to Igneous Lab. So, although this chart might look intimidating, it is, no doubt. This is actually the easier set of rocks to begin with because when we learn how to do this and you look at the rocks themselves, the features are pretty obvious. When we go over to the sedimentary metamorphic, it gets a little bit more subtle. This is a good place to start because again, the features they're apparent. They really will show up as long as we learn this vocab right here. So that's where we're going to start. Now, if you're in my class, you saw this exact sheet when we did igneous rocks. If you're in another class, I'm sure you've seen something similar. And I'm not going to do necessarily the whole entire thing, nor did I post it. I think just you can use YouTube and pause when you need to if you got to go back and see what these things mean. But what do we get? Rocks, essentially igneous rocks, are rocks that come from the cooling or solidification of magma or lava. Consider it the way you might making ice. You've got water at a certain temperature. You get that water down cooled enough below 0 C, and it solidifies. It cools enough that it turns into a solid, right? That's kind of the deal here with a major trick that we got to deal with when we talk about Bowen's reaction series. It's kind of that idea. You get it down to that point, and it cools and it solidifies into a rock, right? So the things you got to look for are the composition. I can put these in here. And the cooling history. That's what you'll be responsible for finding in each rock. And again, if that sounds intimidating, don't worry. It's not that bad. This is the goal right here on where you're going. You got to tell me the color, the composition, then the texture, and therefore the cooling history, whether it's fast or slow. That'll get you the name and the minerals right off of this chart. Okay? So what do these things mean? Cooling history is going to be whether, if you got down here, if you got magma, M-A-G, oh man, that's awful. M-A-G-M-A. It's going to work its way up towards the surface. Sometimes it doesn't make it all the way to the surface. Sometimes it does. And that plays a huge role in how quickly it cools down. The ones that we call intrusive, and again, this is what you'll need on that lab, cool slowly. Because they're like insulated by the overlying layers of the earth. That allows them time to cool down very slowly. They're also closer to the warm part of the earth down here. And what that's going to give them is like a property of having what we're going to call a coarse texture. And when I say that, and a rookie mistake in all of this is that texture is somehow how it feels. This is a sedimentary rock, so ignore that. But texture doesn't have anything to do with how the rock feels. It has to do with the size of the grains that make up the rock itself. So when I say coarse, what I'm really talking about there is that they're like visible. You can see them. Visible. So as you go through your rock drawer in the lab, and again, if hopefully you watched that first video, within the lab itself, Igneous, there's a rock drawer. So there's all your samples. As you go through your rock drawer, which one has the coarse visible crystals? Another reality is that some of them come popping out onto the surface of the earth or get very close to it. In which case, because it's cold up here on the surface of the earth, if you're magma, even if it's a hot day in a hot place of the planet, it's cold to magma, it's going to cool quickly. If that's the case, there's a couple of different options. You're either going to get a fine texture, or some special cases, and you'll see these, are that you can get a glassy texture, where it looks, it just literally looks like a hunk of glass, or you get this thing called vesicular. It has gas pockets. And that's from gases trapped within it that when the pressure releases, they can, like when you open up a 2 liter of soda, the gases can turn into a gas and create all those bubbles, right? If you solidify that quickly, you can get those bubbles preserved in the rock. That's vesicular. Fine will basically be if the coarse ones are visible, the fine ones are either you can't see them or they're really, really small and you'd have to look really close to see them. Okay. And that's half of it. That's half the battle right there. Is it coarse? Can you see the crystals? In which case it cooled slowly, we call them intrusive. Or is it fine, glassy, or vesicular? in which case they cool quickly, we call them extrusive. Halfway home. Composition is what are the minerals that are actually in the magma, therefore the rock itself. We've got like, this is really like a continuum. This isn't like three discrete categories as much as these notes might make it seem that way. But felsic has more, I should stick to typing here, right? Has more Si and Al, silica and aluminum. Mafic has more Fe and Mg. If you say, well, how the heck am I supposed to tell that? What this does is this gives it a light color. And particularly if you see pink, it's a pretty good giveaway. And it also gives it a low density. Now there's a problem because your rock drawer is virtual. They're pictures. You can't pick it up and feel it, right? But you can rely on this color thing. It's going to get you out of most of your problems. Over here, dark color. Like look for mostly black. And then again, of course, the thing you can't do, the high density. What's intermediate then, this will be in the middle where you get like 50-50 black and white. Which, if they're visible crystals, you can see that. If it's fine grained, they're kind of so small that it will just appear to be gray. Okay, there's the other half. So is it coarse or fine? And then is it light colored or dark colored or in between? And if you work all that out, and I won't do this, but what would it look like? An extrusive felsic rock. Well, extrusive, so if it were fine and light in color, that would be that, right? So again, go back on this on YouTube if you need to, because your first job is going to be to, what is meant by those? Fill those in. Tell me that. This is going to be the chart, excuse me, that you used to solve your way out of this thing. So intrusive, there's that term right there, right? These rocks in this row, this way, are intrusive. Extrusive or volcanic, those ones that cool quickly, are in this row. Then is it coarse or is it very coarse? And then over here with the extrusives, is it fine? Is it vesicular? Or is it glassy? Or is it glassy and vesicular? Differences there might be kind of subtle, but I'll tell you what. I'll tell you what rocks that I put on this. And then it's just a matter of getting close and you'll be able to like eliminate and get there. My goal is to make this easy for everybody because I know virtually these labs are kind of tricky. Okay, so it's just really like what we would have done right here. Is it light and coarse? Is it light and fine? Is it dark and coarse? Is it dark and fine? Is it in the middle? Just sort those out. And this table here is almost the same thing. All right, so I gave you 1, 2, I did 9. Let's see how good my memory is. 1, 2, 3, 4, 5, 6, 7, 8, 9. Perfect. Those are the rocks you have in your rock drawer. Okay? Solve for those, and we'll be good. A couple things about Bowen's reaction series. Again, if you were in class, we talked about this, but this is the idea that here's where it breaks from water. Water is nice and easy to say that you got liquid water, it gets to that freezing point, you got solid water. Okay, we got magma, it gets to that freezing point, you got solid igneous rock. But magma is made of a whole bunch of different minerals, and each of those minerals has their own freezing point. So what happens as you slowly cool a magma, your highest temperatures, therefore the first to crystallize are going to be these guys up towards the top. And then as you go down, 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 different minerals will crystallize out of it, which can change the composition of a magma as it cools, right? And therefore give you, and this is why it says corresponding rocks right here, give you different rocks. These two questions are heavily reliant on this chart. If you look at this, you're like, man, I don't know. It's interpreting the chart. Take a minute, take a breath, and it's all on here. Think about what minerals in that case, read what it says, and what rocks would that lead to. Yeah? There, 9 rocks. Give me your traits. This is in Microsoft. I know it's a PDF here, so I could write on it. But it's in Google Docs. So fill in these tables, and it should all be set up to like wrap text as you type. So if you type more than fits, it'll just get bigger and bigger for you, and probably extend onto that page. So give me the color, and then based on that, what's the composition? We looked at that above. Give me the texture, one of those, and based on that, what's the cooling history? Then use the table, give me the rock name, and then minerals present. Glad I looked back at this before we quit. How do we know the minerals? These minerals right here are what make up these rocks up here. So if you find one of them, if you say this is granite, the granite is made up of the minerals that are listed right below it. All these crazy names that may look unfamiliar for a minute, be patient, we'll get there. Potassium feldspar, quartz, plagioclase feldspar, biotite, and amphibole. If you find a piece of gabbro and you look down, it's got plagioclase, feldspar, pyroxene, olivine, and amphibole. So just like look below the rock that you're telling me it is to tell me what minerals belong in it, which of course then relates to what you see in Bones reaction series. So I hope that goes well. And then as promised, what I'll do is I want that complete. And then you're going to do the quiz. And the idea of the quiz will be that you should just, if you've done the work and kind of focused on it and filled this whole thing out, it should be something that you can do in like, I don't know what kind of time limit I'll put on it, but I would guess that I'm aiming to have you do that in about 20 minutes, right? It shouldn't be something where you really got to rack your brain and go back through notes and think about how things work. It should be based on your experience in the lab. Be nice and easy. All right, everybody. Thanks a lot. Good luck with it. Shoot me an email if you have any problems. So long for now.